Hello everyone, I'm Chef Momo, a product manager at PancakeSwap. Today we'll discuss PancakeSwap's journey, our latest iteration of the protocol, that is the version 4, and what's in it for you as developers. So we launched V1 in 2020, end of the year. We were the first DEX on BNB, and we launched the V2 AMM style. Uh, and then shortly after, we launched in 2021 the version 2, which supported the stable swaps, and also implemented the cake buyback and burn. And between V1 and V2, we achieved quite a few milestones. So we were the first $1 billion liquidity project on BNB chain, and then also reached a peak TVL of around $8 billion. Then also held like 50% market share of the total volume across DEXs. Last year, we launched version 3, which supported the CLMM type curve and expanded on multiple chains. We are on a total of 9 chains right now, and we also expanded on multiple product verticals such as gaming, derivatives, and staking. On top of this, cake turned deflationary last year, with meaning that we are now making more revenue through our product verticals as compared to what we are giving out as incentives. So today we are here to announce PancakeSwap V4, and so let's see why we need a version 4, right? So the current version lacks the flexibility and the adaptability to kind of support any pricing curves or add any custom features on the go without re-implementing the core protocol. And it also kind of has huge gas fees, and it's not like perfectly optimized. So essentially, it becomes difficult for developers and DeFi protocols to benefit from our user base and deep liquidity and build upon us. So what do we want to achieve with V4? We want to become the core liquidity infrastructure to support the DeFi ecosystem, and then simplify product development and innovation for developers and protocols, and also introduce gas optimizations for scalability and mass user adoption. And how do we do it? Through a 3-layered modular architecture. So they're like separate modules to implement the AMM models and the custom features through the custom layer, which is the hooks. And we have also implemented gas optimization techniques like singleton, flash accounting, and ERC 6909 support. Right. So we'll look into each of these layers from here. The first one is the accounting layer of the vault, where vault is basically the point of entry and exit for all user operations, and it stores all the tokens balances in this particular contract. So how the flow works is that the external contract or the caller requires the lock with the vault first, and then performs any action such as swapping or liquidity adjustments. Then further, the pool managers executes those actions and then informs the vault of any balance changes and the net settlement amounts of the currency. And then at last, the vault kind of settles it back with the caller in total, right? So this is how broadly the vault works and maintains the ledger of all the transactions. And now the gas savings come with flash accounting implementation, which we'll discuss later on in detail. So from here, I'll like take walk you through like by each step, and then maybe with some code snippets to make it clear on how it works. Starting with the first step, which is acquiring the lock. The method lock basically helps the caller acquire the lock and perform any action like we discussed. And then if the net delta, you can assume the net delta is the net settlement of the currency which is owed by or to the caller. If that is not settled, then the transaction is reverted. Else, the transaction is completed and the lock is released. So this is the method lock. The other one is the pool balance delta, which essentially does two things. So managing the net currency reserves on the pool manager level as well as on the caller level. So you can imagine there are like multiple pool managers, and each are linked to a single vault which has all the token balances. So it's important to update the pool manager reserves, because they all kind of map it back to the vault, right? So there are two things which are done in this method. One is updating the pool manager's reserves based on the caller action, and the other one is computing the net settlement currency which is owed to or by the caller, right? So the next one is essentially what how the transaction happens between the vault and the caller. So there are two key methods. One is take and the other one is settle. The take is used for caller to receive the net settlement from the vault, while the settle is used by the caller to kind of transfer the net settlement to the vault. And now it's also possible to store like surplus tokens in the vault by minting like ERC6909. So you don't need to kind of transfer tokens to and from your wallet to the vault. You can store it within the vault, and you can use it subsequently later for other transactions. So you can mint those ERC6909 tokens and then burn them later to use it. So this reduces a lot of redundant transfer of tokens between the wallets, and results in like gas savings. Now, as we discussed, Vault also benefits from flash accounting. So, in short, firstly, let's see what flash accounting means, right? So, in V3, uh, the typical flow of a multi-hop swap works like at so let's say you want to swap like token A for B for C, right? And then at each of these sub transactions, there would be a movement of token B, for example, from or to the pool, and which changes in flash accounting, which is the V4, where all of these transactions happen at once, and then the net balance is finally settled with the caller. So as you can see in V4, only two token transfers happen, which is transfer of token A and receipt of token C, while for V3 you can see that token B is received and then transferred again, right? So this kind of leads to gas savings. Now the flash accounting also benefits from transient storage, which is enabled by EIP 1153, recently a part of the ETH Denkun upgrade. So, in short, what transient storage does is that it avoids any serialization, meaning that you are now able to store the data temporarily, which is discarded at the end of the transaction, and then you don't need to write or read permanently on a permanent storage, right? So that again saves a lot of gas. Moving on to the next layer, which is the pool manager. So pool manager is something which has the AMM logic, and we have different types of pool manager implementation at launch. The first one is the concentrated liquidity AMM, and the other one is liquidity book AMM. Now the good part is that it's possible to add any other future AMM designs using this layer without any re-implementation of the core protocol. So how it works is that previously in V3 there was a factory contract which used to create different contracts for each of the pools. In V4, all of these pools will sit within the particular pool manager. So pools belonging to the CLMM pool manager will sit inside that, while the belonging to the other AMM designs will sit within that particular contract. What does it? It simplifies the management and creation of liquidity pools, reduces the cost of gas creation by 99%, and also for multi-hop transactions, because now you don't need to move those tokens between different contracts. You can just settle it within the same contract, and that again leads to a lot of gas savings. So the key part here is you can add any AMM logic on the go using this layer. Now we'll look at like how pool managers broadly on a high level, kind of what's the flow with the pool manager. So initially the first thing it does is that we'll check if there's a before swap callback implemented. So this is basically the hooks which we'll discuss later on, but it will check if the before swap callback is implemented according to the flags mentioned initially during pool initialization, and then if there is some implementation, it will execute that logic within the hook contract. Otherwise it will just move on to the next step. It further will then execute, for example, we have taken the example of swap in this particular code snippet. So it will execute the swap logic for the respective AMM type here, and then it will, like we discussed, account for the net balance delta or the net currency that needs to be settled. Further, it will again do the same thing for after swap callback, which will check if there's a after swap callback implemented in the hook contract, and then proceed according to that. So like we were discussing the callbacks previously, the hooks here, which is the custom layer, allows any of so hooks basically are the external contracts which are separate from AMM logics or the core protocol, and it can be deployed by developers, right? So it can be integrated with any of the liquidity pools at initialization, and it's like immutable callback. So once you kind of initialize a pool using hooks with whatever callbacks, then it's not possible to change it. There are 5 key actions from initialize, swap, add or remove liquidity, and donate. And then the callbacks include before and after each of these actions to offer more granular control. Things you could do with hooks include developing order types, dynamic fees, maybe doing some kind of impairment loss mitigation, and much more, right? So we'll take an example of one of the hook ideas and see how it works. So there's like a VCake exclusive access hook, and VCake is a derivative token which is received by the user after staking cake. So the idea behind the hook is that for any of the VCake holders, uh, only those holders will be able to access these liquidity pools for trading or providing liquidity. So initially we start with inheriting the base hook contract, which is already like you can access that in the hook template we have at GitHub, and then it will kind of inherit that and then reuse the helper methods. Now here, like we discussed about implementing the flags for the callbacks, which is setting it to true or false. So for example, in this particular example, what we need to do is we'll only allow swap for any of the traders who are holding the VE cake balance, right? So thereby will flag it as true and the rest of the other callbacks as false. Now for the before swap callback, we'll implement a logic which will check if the user has any of the VE cake balance, and then based upon that, it will let the user swap within the liquidity pool or not, right? Also, on top of it, I'm delighted to announce PancakeSwap $500,000 developer program. Uh, it will consist of hackathons, cake emission grant program, bounty campaigns, ambassador program, and much more. We'll reveal more details soon. And yeah, this is the biggest program we have ever done for developers and specifically for V4. Yeah, and then for today's hackathon, we have a prize pool of $10,000 distributed across three categories. The one is more about like developing a creative hook idea to mitigate the pain points of users or maybe creating something new. Innovation integration is kind of integrating different DeFi protocol ideas using hooks within the pancakes and use PancakeSwap as a liquidity layer, or maybe also having a cross-chain liquidity and trading functionality enabled. And tooling and UX improvements include any data analytics dashboards using which has like the metrics, because there will be a lot of pools once V4 kicks in, given each of the pool will have a different hook. So analytics will become a lot of will have more importance and will be required by the users to kind of take a decision on which pools and which hooks to select from. So you can find more details about this on ETHGlobal price detail page on what are the eligibility criteria and what exactly are the maybe some of the project ideas we have shared over there. And yeah, thank you everyone for your time today. This Chef Momo. I have Chef Burger with me and will help you with any Q&A. Any questions?
I've joined the workshop in the middle. Sorry for that. But I have a question regarding the hook. Can you re-explain what is it about the hook, please?
Yeah, okay. You want to understand the hooks, right? Okay, so hooks are, you can assume hooks that previously there's a liquidity pool. There's no possibility to add any other feature on top of that liquidity pool, right? Now it's, so hooks are externally deployed contract which where you can deploy certain logics at any of these key actions. So for example, swap, right? There are two callbacks which you can implement. So let's say before you swap, before the swap method is called in that particular, let's say swapper comes to a pool and wants to swap, right? There is a possibility, and that is what hooks enable, that you can implement a logic before swap and after swap. You can define a contract which will implement this logic, and then you can, while pool creation, you can kind of mention this hook contract address. So ideally every time any of the swapper calls swap, before swap will execute your logic defined in the hook contract, and after swap will also do that. So it's possible to kind of implement any type of logic. For example, let's say custom oracles, right? So you want to, let's say, relay, you want, taking a simple example, you want to create a median oracle which takes the median price of the last 10 data points. For that, you need on every swap, you will kind of update the latest. You'll fetch the latest pool price, remove the last one, and then take the median whatever price from that, right? So you can keep on doing that, and then anyone else can use that particular hook to get the so it can work as an oracle, right? So you can implement any of the complex logics using that. So we don't need to do any of the protocol re-implementations, and yeah, so the possibilities are like endless. Yes. Yeah. Thanks.
Do you have any example repos for existing hooks that we could use as a template or starting
Yes,
point?
yes, you can find that at our GitHub. We have also mentioned that in our developer docs, as well as the resources under the global page dashboard. Yeah. Any more questions? Yeah.
Why the mask? Corona is over.
Oh, it's a brand now.
Is it brand? Funny.
Yeah. Yeah, if not, then if you have any questions about V4 or the develop program, please reach out to us at our booth. It's located just at the entry, and then yeah, happy to answer anything. Thanks, Evan. Yeah.